Good evening. Well, thank you for coming on to my channel. If you came here to watch me do some drawing, well, stay tuned. I'll be doing that later. Now in this video I'm going to be explaining about vacuum tubes. The basic working principles, how they work, their amplification properties, and the comparison to transistors. So starting off with the working principles. Now suppose we have an evacuated glass tube. There's a vacuum inside it. We have a filament, much like that of light bulbs, that heats up. Now it heats up to a yellow hot temperature. Now around this heated up filament, which we call the cathode, the electrons are boiled off of the metal's surface in a process called thermionic emission, and we have a cloud of electrons that surround this cathode. Now these electrons are naturally attracted to a positively charged plate. So suppose we added a positively charged conductor inside this vacuum tube, and let's call it the anode. These electrons will now form a path. We can complete the circuit, and we have a vacuum tube with rectification properties now. If we try to make current flow from the anode to the cathode, it won't work because there's no electron thermionic emission coming from the anode, only from the cathode. So we have a two-terminal device if we not include the circuit that heats up the filament. Now suppose we added a third terminal in between the anode and the cathode. From now on we're going to be using a conventional current flow. So current will flow from the positive to the negative. And we know that current only flows in one direction, in the rectifier. So now suppose that we have a grid that is placed between the anode and the cathode. This grid is a fine metal mesh with mostly empty space on its area, but there's some conductors that creates a mesh. Now the voltage that we apply to this mesh dictates the amount of current that flows from the anode to the cathode. If we apply a negatively charged plate, or if we applied a negatively charged grid with respect to the cathode, the electrons will naturally repel the cathode and it will not reach the anode. Now if we apply the inverse, if we apply a positively charged grid, the electrons will be further accelerated towards the anode. Most of the electrons would flow through the grid. Most of them won't hit the grid. Now we see that it has amplification properties as well. It's able to convert a small change in voltage to a change in current. Now much like BJTs, they both have amplification properties. They also have three terminals in this case. A vacuum tube can have more than three terminals, but in this simple case we'll stick with three. I'd like to compare the base of the transistor to the grid of the vacuum tube. That is the thing that dictates the amount of current that flows between the other two terminals where much of the current flows. I'd like to compare the anode plate of the vacuum tube to the collector of the transistor. It basically acts as the positive end from which most of the current flows. And similarly, I'd like to compare the cathode of the vacuum tube to the collector of the transistor. I'm talking about BJTs, of course. So yeah, much of the current flows from the emitter, or from the collector to the emitter. That's where most of the current flows. The only difference is that the transistor, the BJT transistor, converts a current to an even larger current. That's the only thing, but conceptually it's very similar. So thank you for watching. If you want to watch me draw, stick here, stay tuned. I'll be doing it in a second.